Hello, this is the Blast Report podcast on all things blasting. My name is Evan Tebow with New Wave Consulting, and I want to thank all the drill and blast teams along with those supporting them who are out there on the pattern. The production team at Blast Think and I would like to welcome you to today's episode of the Blast Report podcast. This episode of the Blast Report podcast is brought to you by WipWare. Since 1986, WipWare Photoanalysis Systems has provided solutions for fragmentation optimization. WipWare is a global company with influence in any industry where fragmentation is key to success. They not only measure and monitor materials, they create actionable data. Your mine-to-mill process can be optimized with their available hardware or software options. Whether you use drones for blast photos or you install one of their industry-leading real-time cameras along the haulage process, WipWare creates solid analysis to confirm your blast design is the most effective it can be. This small business has a big impact because you can't manage what you can't measure. Was there any other? I'm sure there was, actually, especially when we're talking with that size borehole. Was there any other type of, let's say, common failure modes when you were working with boreholes that size? I mean, a lot of people don't get the opportunity in their whole career to even see a 10-inch diameter borehole, let alone 15, 16. What are some of the factors that you can give to our listeners that are crazy? I remember one time just being up that far north, so we were using stakes to stake into the cuttings because the pile of the cuttings is massive. But the cuttings at certain times of the year, you couldn't hammer the stake in. It was frozen solid. And you couldn't even beat it in with a sledgehammer. The stake would just shatter. What were some of the other, let's say, difficulties that you remember operating with borehole diameters of that caliber?
Well, it was the rule, not the exception, of these big holes. So, it's interesting to stop and think, what would other people be surprised about that size hole? The cutting pile, certainly. The drillers had instructions, and they had a rake, and it was for the safety of the blasters, because once you had the cutting pile and you had snow and ice on it, then you have to walk up that pile. Now, that pile would be head high. If you had a 60-foot hole, which we would sometimes drill that deep, you had a giant anthill. It was sloped and it was slippery, and somehow you had to climb up and do your work. So the driller had a rake, and of course, raking that all down is quite a bit of work. And so it was always a lot of training and reminders that, hey, your buddies on the blast crew are really fighting it because you're not raking those down. So I can think of that one.
That's a good point.
Of course, with a 16-inch hole, one thing that's different is you don't get much hole wander. That steel is so thick and stiff, and you're not drilling 100-foot holes or anything like that. So, but we always still had problem with hole placement. When you're getting out those big diameters and you're out at 32 by 32 feet, or even out to 36 by 36. And then it's a cleanup isn't done properly, so they can't get a good setup with the drill. Well, then they'll move it over a little bit and then a little bit more. And especially if you had an escarpment in the pattern, on the top cut of the bench, and and you've got this step where it's native top ground, top of formation, but then farther down the pattern, the ground had risen, so you had taken a bench off, and so now you got a step. Well, now you got a pattern that goes across that line, and that step in there on the cleanup, you got to clean up really carefully down on the bottom side of that, so the drill hole can get in close to that bottom. And people often say, well, with that big hole, all you do is just load that a little harder. But I'd go and measure, and sometimes those holes would be 60 feet apart, and nobody they wouldn't believe me that when you would actually check it. And so you can load it as hard as you want, but one thing you're going to do is you're going to blow 15 feet of stemming that much higher, because that's the path of least resistance. Yeah.
And the size of the boulders that get left in that application, I think we found that, it increased the price of the drilling, but we got better results when we decreased our borehole diameters and just had more uniform powder distribution in the product. But one thing I seem to really remember, and you mentioned it before, is just there was no such thing as really a good collar because of the preconditioning of the bench below. I mean, it was so difficult, and watching the amount of material falling into the borehole while you were loading, it made for catching a VOD difficult. It made for steady state velocity because there was always so much of everything falling in. That really threw me through a loop, and I could never really tell if the post-blast fumes came from everything that was mixing with the product as it was falling in, or if it was the sleep time because of how long you had to wait before you got an entire pattern with those holes loaded.
Yes.
Do you have any sort of stories or knowledge on or recommendations on how you'd handle something like that?
Yes, something that we sure dwelt on that, and when we talked about mentors, I'll weave one more guy into the answering that, and that's, excuse me, and that has Butch Mackey. He was a tech for Dyno, and he's been retired for 10 years now. But he brought, back in the day, Frank Chiappetta really pushed a lot of the instrumentation. And so Butch would go and buy the early VODs and some of the cameras and some of the various items, and then and because this was leading edge, he would meticulously go through the manual, read, understand, and he'd say, "Hey, Frank, this doesn't work. We got to do this and this." So I mean, people who stop and study manuals and really take the time to understand and have that patience have a special gift. And and we could never get a clean VOD except for on the cap hole.
That makes me feel better, Jack. You just made me feel so much better about my life. It's a nightmare getting a VOD on anything other than the initiation point, in my opinion.
So what does that tell you about what's going on in that borehole?
I would say, one, you're getting either preconditioning from the adjacent borehole, the one that's before it, or just sheer cutoff, were probably the two ones that I always blamed. You weren't shooting fast enough at our application because you weren't catching any of the VOD. So I guess those are three that I can think of. What would you suggest?
Well, what led me to this is you're talking about stuff falling down the hole, and so what we did with a number of holes is we got them all wired up with cable, and of course, in the old days that was a lot more work than it is. You use I don't even haven't done any VODs for a long time, but it's a lot easier than it was then. I understand. But what we do is we go and start shoveling cuttings and stemming in, and shovel in, and we just estimate this 1 foot, 2 feet, 3 feet of inert material, and then to see at what point do you lose, do you cut the hole off, that it dies out. When I think we're using top and bottom initiation probably in those cases. So then you would see that it would pick up again when the upper one was delayed. If you had if you had a 200 millisecond delay down at the bottom, and then you had a 250 or a 300 up on the top, and then you had this inert material in between, and then you could say, okay, how much does it drop off, and how much does it pick back up on each, on the far side of this inert material. And I never got back to do the studies, but we could hardly see any drop off.
Wow.
And part of it is because I was told, one of the theories that somebody advances, if you have a 16-inch diameter flame front, and the amount of pressure that's exerted through that stemming is tremendous, and it picks right back up again. And it really makes me think about people who use short decks.
Yeah,
that shooting
back of my head.
Shooting through. After doing that, I said, "You guys are doing all this decking with short decks. You're wasting your time, because and maybe it doesn't behave so dramatically in smaller holes, but in these 16-inch holes, it just shot right through it."
Wow. I was thinking the same thing when you were saying that. I was like, man, how thick does a deck have to be? You're essentially doing an industrial scale UN gap test.
Yes. Yeah. Yes. What is the rule of thumb 6 hole diameters for a deck?
Got me beat. I don't remember what the rule of thumb is.
I mean, there's a number that people use.
Yeah.
But I don't think we ever got up to 6 times 16. I mean,
right.
6 times 1 1/4.
It might not be that linear.
and by that time you don't have much hole left unless you're doing it way down the bottom.
Yeah. Right.
Yeah.
Wow.
Yeah.
And was post blast fumes a big deal for you guys then, because of sleep time mainly, or? Yeah,
we had towns downwind, and we could have some blaze orange clouds. And the best that I could tell was, and you probably saw this when you were in iron ore, is that there's these knife edge contacts between gray taconite and then red hematite, where it's oxidized, and it's just it's red dirt, and you can see a pattern, and there's many films, videos to show it, that the pattern is just coming along beautifully in the color. And of course you don't see the color. The color comes a couple seconds after, you see the blast up, and then as things start settling, then you start seeing the red start billowing. And I can't prove it, but I would say the anecdotal viewing of it is pretty convincing that as soon as you lost confinement, that's when we started getting red. Yeah.
And we would always say that where it hits that soft rock.
Oh, exactly. We would have rainstorms, and it's not too bad on a regular bench, but when you're top of formation, it's an undulating surface, and you get 6 to 10 inch rainfall event, and it all gushes into the low areas and just runs through there. I recall walking on patterns where 20 or 30 holes. You'd walk and you look down, and you could look down 20 feet in the hole, and it was, the afternoon before, it was all loaded and stemmed up, and you'd say the inflow was completely washed out of there. We really had no solution for that. We just wired them up and shot them, and I don't know how we got it to dig through, but those rope shovels were pretty powerful.
Yeah, they are. So when we did get kind of technical on some of these and part of this conversation here, and I just find it fascinating because it's been a while since I was in the Iron Belt and had some of the most interesting years of blasting for me was dealing with constant change, or just the issues that you would see, one with weather and two with that kind of rock and borehole size. There was always something going on. What would you say out of your career in this medium, okay, what would you say was one of the most challenging variables you had to work with? And then what would you say was one of the most, and was that also the most enjoyable variable to investigate? So one that pissed you off, or one that you were like, this is why I enjoy blasting here? Was there any sort of, you see what my question is, where I'm going with that?
Yes, and are you talking about
more the rock, or more not so much people or anything, but more in that type of mining application?
Yes. Well, the iron ore, the cost of iron ore pellets, the mining is around $2. It was back. This was back in the day, because costs are way different now. But to make a pellet, before you applied any shipping or royalties or anything, just some of the production costs to make the pellet, we were aiming at a $20 pellet, and these are old dollars, but they sound silly, but with inflation stuff, the relationship is still the same. But out of that, $2 was mining, $18 was processing. So, wow. The thing about iron ore is that it's so energy intensive, and so much of it all depends on the processing costs, so what was a little hard is to get people to pay attention to the mining. That if we blasted properly, and I am talking people here, but it is the property that you're taking this down to face powder size. And early on, I got involved with some of the guys in the plant, and I am straying off here, but the mine and plant in many places, and it was no different where I was. They're the north versus south, the gray versus the blue.
Always.
But I consorted with the enemy, and they didn't. A lot of people didn't like that I go, and I was lucky because when I broke in, I spent a couple of years in engineering working under the geologist, and his office was in one of the plants, and so I ended up spending time and got to know these guys and found out where a lot of the data was, and so we were starting to. That's another whole story about marrying up mine to mill data. Mm-hmm. But the things that stick with me about the rock, we had very blast effort. We had vary it from, we got to hit this hard, we can go a little easier here. We varied the blast effort over a small range. We did it over maybe a 0.5 up to 0.7 powder factor, somewhere in those range, and that's pounds per long ton. And that's a fair range, but the rock varied tremendously. I sent some samples to the U.S. Bureau of Mines on a project I was working with the USBM in the Twin Cities Bureau, and the published value for taconite was 45,000 psi, with a harder areas being 65,000 psi. Well, some of the samples that I sent were 125,000 psi.
Whoa.
So it turned out that if you did a correlation between our powder factor and the blast results, you found out that the highest powder factor gave us the worst results, because we started getting dialed in on what was hard and soft, and we were under constant pressure to keep the cost down. So we'd apply more power to the tough areas and less to the soft areas, but never enough to make up for it. So the high powder factor areas always had the most chunks and the lowest throughput in the crusher, which is counterintuitive until you stop and think about it. Yeah, but if you're hitting it a little bit harder, but the rock's a lot harder,
there's nothing you can do.
You won't see that it would only have been worse. So,
well, tell me more about this mine to mill, Jack. Like, was this? Please tell me you're the one who came up with
that's not true.
That'd be
no. I sure hopped on the bandwagon, and I was not the first, but it was up in iron ore in Canada that somebody in 1963 did just an outstanding job on that, and published a paper on it, and I was just shocked about what the relationship was. Yes.
And you were able to, and so, I mean, I can't go to a meeting now without hearing that.
Yes.
And I know that trying to, people will say that, every company will say that, oh, we're going to look at this mine to mill, what's your downstream effects and stuff. But then when the data actually really comes, there's so many variables.
It's a lot of work. It's not. Yeah,
it's a lot of work, and people are, we'll look at the electric throughput of the crusher and tell you that, and then you're like, well, then you talk to your friend who runs the crusher, and he goes, well, that's not going to tell you anything. There's a million things that go into that value right there, and you're like, okay, but help me out here. So what is it that you found that you decided you wanted to build your career on? Like, what was it that fascinated you the most, or that you enjoyed doing in that? Was it the collaboration between all the sides? Because you said you kind of enjoy that talking to the neighbors side of work, but is it something like being able to get everyone in the room together and hear out what they're
well, no, it was my fascination with the data. He never could get everybody in the same room. And they went, yeah, they went.
You were a wizard.
Talk to each other, but your story that you said about electrical consumption at the crusher, I use that story the same back and forth. You can't use that. And then I'd go to the shovels and use the shovel loading speed, and the foreman would laugh and say, you can't use that. Some of those shovels are dogs. And then some of the shovel runners don't know how to run it. And then crusher hang-ups. But what I decided is that none of those is not just a three-legged stool, but multi value function, where we take and weight all those things, and then like on the crusher, they told me, they said, well, you can't use the crusher because as that mantle wears, the geometry becomes less and less favorable, and it starts drawing higher and higher amps. And I said, well, when you put the new liners in there, we'll just put a degradation function in there, and we'll just prorate that. And as it gets towards the end of life, then we'll put a handicap to those scores. And with the shovel runners, what I did is I took not using names, but the guys' check numbers and what their average loading speed was, and did that for the shovels. Not a really big job. Hang-ups and that, and we just started putting those numbers together, and it was eye-popping. It was just eye-popping what powder factor, and then the other part was knowing what your formation, what it was like, whether you're looking at your hard part or your soft, or what were you up against there. And I can tell you, some people like Highland Valley Copper, did projects with them. Very sophisticated system of they had their drill monitors, and I think they still do that. It's been a number of years since I've been involved with them, but the drill monitoring, they had that calibrated to line 6 rod mill or a ball mill, line 6 ball mill throughput. Their line 6 was the one that they had the most instrumentation on, and that they had the pulse of it. And so instead of having a rock hardness indicator, when they'd combine the down pressure, the RPM, the feet per minute, and all the torque and the factors there, they calibrated that back to line 6 throughput. So now when they go out and drill that pattern, now you tend to lose track when you have stockpiles like they do, where you build stockpiles and then you're taken from it, and it gets so sorted in that pile as that cone goes up. But just very, very innovative, and the more I looked at it, and to this day, I'm quite shocked that mine mill is not is still it's kind of a shiny object that people kind of reach for, but they don't. The people who aspire compared to those who achieve is it's not even 1 out of 10. No. And I could be, you're talking to a 76-year-old guy who's probably a little out of touch, and you'll probably hear some people say, "Wait a minute, Jack, you're off in the woods there in Minnesota. You're not following me. We're doing this and this and this." So I'm ready to be corrected too.
Well, that's humble of you to say that, but even for me, I can see when it really starts to come down to it. You start talking about prorating the degradation of the crusher and things like that, and just getting in the ballpark, just getting in left field is a win for most sites.
That's all you need for your first go around at it. Yep. Yeah. And what
so interesting.
There was a lot of Russian research from the 60s, and that it took 20 or 30 years for it to make into Western literature. And if you believe what they came up with, it's just astounding about the efficiency of making new surface area and rock with explosive versus crushing and grinding. And when you look at it, that one number I came up with, just looking at the energy inputs, some would say that it would be a 7-to-1 advantage that blasting has over mechanical. Of course, and crushing is order of magnitude or more efficient than grinding. Over 99% of the energy that goes into a ball mill, into a rod mill, does not go to making new surface area. So it's just, when you say that those are machines to break down a rock, the breakage of the rock is just kind of a little sidelight off on the side. They mostly just heat up the rock, and they mostly wear out the liners, but less than 1% of the energy that goes in reports back as new surface area. So it's extremely inefficient. Of course, you can't, you can't do that with blasting, but you want to do as much as you can with blasting. And you need to be extremely curious and to just really keep looking at it and saying, can we do a little bit better? But when you look at the performance of crushing and grinding circuits, and you look at the noise in the data, there's a tremendous amount of noise, and you really, when you're talking about these small changes or improvements that we think we can do with blasting, you can't see them day to day in the operation of the plant, but you really have to look at it, at the months, and you can see it. And I have this challenge to people who don't believe that this can be done, and they say it's too expensive to test, and you really can't see it anyway. Well, I say, don't change your drill and blast budget one bit, but let's go 1 month at a time and go 10% more energetic blast 1 month, and then go 10% below the next month, and let's do a sawtooth for the year, so that if you charted how your blast effort went, it goes up and down and up and down, and
but you're
same budget. Now, now take a look in your crushing and grinding circuits, and see if you can see that sine wave in there. And that's kind of skunk works that you could, because blast engineers often have some latitude in how they design that pattern. They don't even have to tell anybody they did it. They just
true. No, you're right.
And
10%. You're right.
And so now you're looking at a 20% delta. And if that, unless you're blowing that energy out with very poor designs, you should be able to see it. Yeah,
that's very.
And I think a lot of people are a little afraid to try it.
Well, I'm going to take that advice instantly. I'm going to bring that to any location. I hope our listeners do too, because I really like, oftentimes people are always like, we can't afford to do those studies. We can't afford to do those studies. And that's if you came up with that, or whoever your team came up with that idea of altering inside of your budget, that gives you meaningful data that you're changing within the realm that you're allowed to do. And that's step one. And then, next year you've got enough data to come bounce back at somebody and say, okay, here we go. Look, now this is what we need to do. Or this is what we should do. So that's a great lesson. And I wish that I would have heard that years ago.
I probably wore out some people's attention talking about those things. I've given my mind mill spiel 100 times in different training and talks. Where I came across my first evidence of that was Dave DeBruin ran the concentrator, and the concentrator at the Mentac mine is a 1/4 mile long. It's a huge building, and they use a lot of electricity. Their power bill right now is $6 million a month. So they're really pounding away. And in the 80s, when all the iron and steel companies were going out of business, and the U.S. Steel is trying to stay alive, they said, okay, we're cutting everybody's budget, and you got to come up with a plan for the next year where you cut your budget. And I told my boss, I said, I got the easiest job in the world. All I do is just spread the pattern a little bit, and we saved it. But I said, we we drill and blast at this level for a reason. It's not that somehow you can make smaller rocks with less. And
Right.
it's drill bits, man hours, and powder. And so I told him, I said, I'll do it. You don't want me to, but I'll do it. Oh, okay. Well, we'll exempt you from it. And the next year, the same hammers coming down and things are still bad. Jack, you got to cut by 10%. I says, I could do it, but you don't want me to. I can tell them the same story. And so round 2, drill and blast was exempted. Well, the third time it came around, my boss says, Jack, don't even bother telling me why we shouldn't do this, but we're cutting it. And it was the best thing that ever happened because we made a big change. And my friend, and okay, excuse me, but in there, we cut it. There was some problems, and I think we had a change of leadership or whatever. We went back up, and then we went down again. Anyway, we ended up with a W when all was said and done with our charting it down, up, down, up.
Mm-hmm.
Well, Dave came to my office one day and he had a printout, and I saved it because it was the most valuable thing in the world, and he put a big question mark on it, and it's just a plot of the throughput for the rod mills, and it was an M. It was a W and M. So this wasn't a test with 2 points. We went up, down, up, down. I mean, and it matched. It was just a complete mirror image.
Right when you
Yes.
made that change.
I mean, you could be deaf, dumb, and blind, and you still could see it. It was so obvious, and it was like, how could it be that tight? How could it be that such a relationship? And at that point, since then, no one ever has been able to tell me, oh, that really doesn't have any effect there. These other variables all wipe it out. But I
just take that photo and hang it on the wall.
It's somewhere in the stacks and stacks of stuff I have. But I've reproduced it in other forms, but I don't have that original. And I've gone in, and there's 2 operations who I won't name because some of the people are still there, where we went in, made a change, and I had somebody come to me and say, Jack, you wouldn't believe what results we got. I'm going to give a paper on that next year, and all excited. And I said, boy, if you need any help with it or anything, this is really exciting. And I got busy, and I didn't run into him for a while, and it was a year later, and I talked to him, and he says, oh, we quit doing that. It didn't work anymore. And I had almost the identical thing happen at a second place. And I imagine that these guys got taken to the woodshed and told that you're not to do anything and you're not going to work with Jack, and just forget this BS completely. But I had 2 cases where these were home runs, I thought, or I was told they were home runs.
Did you ever find out
Never.
kind of why they weren't
No,
home
and
runs? Did they used they made the changes and then someone made a budgetary change, or there's something else that came in and switched the drill bit style or the size of the borehole, or changed something that they never told you?
No, and in fact, where I was making some of the changes after I discovered the W versus the M, and then I was talking to our general manager, the guy who's in charge of thousands of people at the operation, not just the mine manager, and he confided to me. He said, yeah, some of your stuff probably is good. He said, but we needed to attribute those savings to the rebuilds. Some of the some of there was it was $20 million rebuild on ball mill. In fact, some of the ball mills were going to fall through the floor because the 30 and 40-year-old beams had rusted, and they needed to come in big time and really redo that. And so the general manager told me, he said, we needed every penny of justification we could to apply to say that our rebuilds were doing this. And if we came back and spent more on powder, because they wanted to go back and say, okay, we saved all this with the rebuilds. Now we're going to do, because there's 18 lines, we need a whole bunch more to do now. So they wanted to pocket the difference. Yeah, and somebody in blasting told me, he said, don't try to take credit for improvements in the blasting. The guys in the mill will be patting themselves on the back and taking credit for any improvements. I don't think that's always true, but in some cases it might be.
That's a pretty funny one, though.
Yes.
That's a good one. That is absolutely good one. Well, Jack, let me ask you one more question here. Maybe even two, but I'll give you one here. What is something that you're looking forward to in the explosives industry, or in the explosives application in your let's say if it's your region in itself, something towards the future here? Is there something that excites you looking forward about how they're blasting, maybe mine to mills or something like that?
I'm a one-trick pony, and it's the mine to mill that is far and away the top. I'm very interested in now Mike Indahar is a very innovative engineer at one of the local mines here, and he just retired a couple of years ago. But he went on a big move to what you had alluded to, and that is smaller holes closer together. And obviously that does give you more control. If you take it to the extreme, let's say that, well, you just use a raised boring machine and make a 6-foot diameter hole in the middle of your pattern and then load it with explosives. You can have the same powder factor, but that's quite different than doing 4-inch holes on a 6 or 8 foot pattern. And the joint spacing, if you got an open joint and you don't have a hole in that block that was formed, your chances of really shattering that area of rock are low. You're probably going to displace it and throw it, and you're going to have chunks made out of it. So the more holes you've got, the much more uniform results you're going to get. But anyway, Mike published a fair bit of data on how to do that. So I think that's an exciting area. I think measuring results it's getting so cheap to measure results today that it's an abomination that people are not employing WipFrag and split. And I had a relationship with split for decades. With WipFrag for decades, and Tom Palangio and Thomas, what outstanding software and hardware and support. Just a outstanding bunch there. Smart people.
Absolutely.
Oh yeah,
yeah, I like him.
Very, very top notch. And we've installed dozens. I could say dozens, and certainly more than a dozen. And when the belt gets changed out, when you got a 1/4 mile long belt from the crusher on up to the stockpile, they have to take everything apart, and they're in a hurry, and then they don't put them back in. Or where you have truck dumps and stuff, I go out and I say, they had a crane working there and they wiped out the camera and nobody got back to it. And the cost of these is extremely low.
Right.
And I go back to basic measurements. chemistry and a lot of that couldn't come along until Fahrenheit invented the thermometer. You need to know where you're at before you know where you're going. And so many of these things are now available. And they're highly reliable now too. Some of the stuff when I got started, is DOS based and fragile. Nowadays things are armored and so some of these devices, I can tell you that they'll and this is almost like a sales pitch, but they'll pay for themselves in the first month of operation. Yeah, they really are pocket change compared to the losses that you suffer from not knowing what's going on. Yeah, and so measuring and then tying it back to the ore type that's coming in. If you can start to characterize your ore body, and you know it in all three planes, that is it. Where are your hard areas? And I always got a kick out of Tombstone Corner is where we got a lot of our chunks from. And that was a place in one of the pits. Yeah, that came from Tombstone Corner. And then you start mapping out where people say it is. Well, it depended on the orientation of the blast compared to the dip direction. And it moved around, but if you don't measure something and mark it down and to have good notes, it all kind of blends into one. But no, that if you really know where your chunks are coming from, then you've got a little bit of chance of doing something about it. Yeah,
very true. And having the personnel on the team who can translate that data into what you're actually doing. I know there's so many places that they don't have a person. They got all the data, they're measuring data, but no one's looking at it. No one's actually going through and tying things together. And so that teams actually pay attention and have someone on their team who can do that is very valuable too. On top of what
absolutely. The front office they say, well, we bought that instrumentation, so we're done with the project. Well, that's when the project starts a lot of times. That's when you have to start getting into it. Now, Tom Palangio has a saying that he likes using, and I just love to quote him on it. And it said, data really it doesn't have very much value. It's just a lot of numbers. You've got to comb through for, screen it and get the zeros out of it because you're getting no signal sometimes, and if you just look at the raw data, it's not telling you anything. The outliers are skewing it so much. You have to boil that down into information, and you have to corral it into information. And now you study that information, and then from that you derive knowledge. But so you've got data, information, knowledge. Now, when you buy the equipment, put it in and start printing it out or storing it, and a lot of places, that's all they do is they get it and they just start storing it. No, nobody has any time to look at that. No.
I've heard that before. Yes. Well, thank you so much, Jack. I really appreciate you coming on the show. It's a wonderful interview, and definitely learned some things here. It's awesome bringing back the memory of some of my time in the iron and seeing that there's some similarities there across the border. And just nice talking to you, and I hope I get to see you again at one of these conferences. And like I said, thank you so much.
Well, all I can do is thank you, Evan. You're doing the Lord's work, and you're keeping the ISE going. It counts very heavily on a small number of highly motivated people, and I count you as one of those.
Thank you.
Yes.
Means a lot.
Well, have a great weekend.
That. Hey, you too.
Right, bye-bye.
You take it easy.
Thank you for listening to this episode of the Blast Report podcast. I want to thank the team at Blast Think for producing this show, and please follow along for more episodes in the future, and share this podcast with your colleagues so we can continue to honor our industry and the people in it. Be safe and have a blast.